Hello everyone, I'm Jianhong Mu from Oregon State University. The talk I give here is climate change impacts on agricultural land use decisions in Pacific Northwest. First, I have to apologize that I changed the title a little bit. So I was trying to short the title to fit that one-page template. So I hope it doesn't cause any confusions for that. But title is the title. The stuff I'm going to talk here is the same. So anyway, when we talk about farmers, they want to change land use to maximize the returns from that land use. And so they could switch agricultural land use to non-agricultural land use if the land value is higher for urban development, or they could allocate land for more land for crops and less land for livestock if the price of crop products are higher. So to them, changing land use kind of risk diversification strategy. They could to reduce the risk and balance benefit from uncertain world, and also it could be adaptation strategy that they could enhance the benefit or reduce damages from climate change. And when we look at the historical data for the Pacific Northwest region, from the right bottom graph, you can see in this region, crop and pasture land declined, conservation land increased in the past 20 years to correspond to changes in climate. So in the future, it is interesting to know how land would be allocated to under the environment with uncertainties of climate and also some socio-economic development. Theoretically, farmers make land use decisions based on their expectations of market prices, government payments, soil conditions, climate conditions, and some other socio-economic conditions, etc. So we have a full discussion of the theoretical background of this question. And here, in an economic sense, we could use a reduced form to assume that land use is a function of these variables. So we could use county-level data from 1982 to 2007 in Pacific Northwest region to first estimate impacts of historical climates on current land use patterns. Second, to predict changes in future land use using projected climate data from the climate teams for 14 GCMs and 2 RCPs. And also we could simulate land use allocation by the mid-century for 3 REACCs we developed for this region to capture the uncertainties in the future world. Here are the estimation results. I skipped the estimation models and the big tables because I don't think you want to see these equations for my presentation. But if you do, you could let me know, and I will send you a copy of my paper, and I'm sure you will enjoy it. So anyway, here are some summaries from our estimation results. First, we found that climates have statistically significant impacts on agricultural land use. So that means future climate change matters when making land use decisions. And the good news is we have climate teams to provide us future climate, downscaled climate data. So that part is okay. And the second, we found that market response are important indicators, and more land will be used for production with higher market returns. And the third, increase in population density will increase the demand for food. So in that case, there's more demand for cropland use. And also we found that irrigation has significant impacts on crop production in this region, particularly in the summertime when there's a shortage of water supply with increased water demand from previous literature for this region. So based on the last 3 findings, we think that changes in prices, changes in population, and also changes in land use management, such as irrigation, matters in the future. And fortunately, we just develop the REACCH for this region, and we could use the REACCH for the land use analysis as well. So this graph gives you a sense of the relationship between precipitation and agricultural land use. Here in our paper, we include a 30-year average precipitation to indicate climate change and annual precipitation to indicate weather variation. But no matter which climate variables we include in the model, we see there is a nonlinear relationship between precipitation and agricultural land. For example, you could say cropland, the blue line, will increase first and then decline later as precipitation increases. And if there's more land used for crop, less land will be used for livestock or conservation use, and vice versa. So when we look into the future, here are the predicted future land use changes on the climate change scenarios. We use data from the climate team for 14 GCMs for RCP 8.5 and RCP 8.5 from 2035 to 2095. The light color shows the earlier years and the dark color shows the later years. So you could see from this graph, cropland and pasture land here, the third row, will increase at the early period. However, as climate becomes more serious in the later period, there's a large increase in cropland, but less increase in pasture land, and less reduction in rangeland. And you could see on the RCP 8.5, there's the results, the changes in land use spread out. So there's meaning that there's more uncertainties associated with a higher emission scenario. As I mentioned earlier, we think REACCH are important for farmers to make land use decisions in the future. So we use the 3 REACCH developed by Antle and al. 2014, and to calibrate parameters in the land use model. But here, I changed the variable. I would adjust the variables in the land use model to correspond to each REACCH. The graph here shows the future land use changes on the climate and REACCH by 2015. And the blue color shows the climate impacts. The orange, green, and red color shows the results impacts from REACCH 1, 2, and 3. So from this graph, you see the impacts of climate change are offset by the impacts of REACCH. And there are large variations across different GCMs, RCPs, and REACCH. So it's important to consider not only the climate change for future land use, but also some socio-economic conditions. Okay, this is the last slide of my presentation. We have discussed which box our study could fit to, and finally we found one that the integrated models, scenarios, REACCH. And I think that because we use the data from the climate model and we have REACCH in our study, I think that's the most important point. So that's it. Thank you.